Engineers, so we're going to do a second example sorting cards, talking about a slightly more difficult flowchart as well as code. So now instead of just sorting out the black cards, we're going to figure out those that are less than 5 in value and put those on a pile to the left. So that means in this image of all the cards, I'm looking for these 8, really, from ace to 4 for the spades and the clubs, and then discarding all of the rest of the cards. So let's go back to the flowchart that we left off on with just sorting the black cards out, right? So we had, if the card is black, do this, or not, do this, and then both of those led to checking if there were cards left before we end the program. So now that we want black aces through 4s, that's going to change this section right here. It's not enough just to have a black card. So we're going to cross out pretty much everything down there, leaving us with this. So if the card is black, no, we still don't want it, so that's the same. But if it is black, now we need to check if it's less than 5. So that's going to be another decision diamond here. And at this point, we need to see what happens if it's yes or no. So if it is yes, then we do want that card. It's going to be on the left. And if it's no, then we can go back to this and say we don't want that anymore. Put it in a pile on the right. So all these arrows are really useful for showing us our code, because if we are able to reuse one of the previous steps, that's going to show up on our code as a more efficient way of doing it, instead of saying no and then like a new step that says put in a pile on the right. We shouldn't need to repeat ourselves if we can have the computer figure that out. So that'll come up when we start turning this into code. All right, so then after these, all of these need to lead to checking if there are cards left. And same as before, if there are cards left, then we want to go back to the beginning. And if there are not cards left, well, let me show you that. Back to the beginning. And if there are not, then we can go ahead and end the program. So that would mean no over here. All right, so let's go ahead and see if we can turn this into code. So as before, we're going to start with what we had for just the beginning part. So I kind of copied and pasted the code over here. We had the while the number of cards is greater than or equal to 1, and then if the card is black, and then I left a lot of space here because that's where we added if the card is less than 5. But still, down here, else, we're going to put stuff in the right pile. All right, so the first thing that we need to do is we should notice that if we have another branch situation over here, well, now this indicates what again? Another if statement. So that means inside of this if, because it happens after, and it's already sorted all the black ones out before we start to ask if it's less than 5, then I'm going to go ahead and add a nested if statement. So that's this one down here. Is the card less than 5? So I came up with a new command here, so I made this up, but again, we can't just say is card less than 5, because up here we were checking the color of the card. Here we're checking the value of the card. So we have to just retrieve the right information about that card. So the dark blue and then the parentheses is basically saying we're looking for this about whatever's inside these parentheses. So now we're looking for the value to be less than 5. And notice it's called nested, and that kind of looks like, if you think about it as a nest being around something, right? So this is inside, this is like a baby chick, baby egg or something, bird egg, inside of this bigger if statement, and this is the nested one. That's just the term used for it. So anyway, now we know that if the card is black and it's less than 5, we're going to follow this instruction down here, which is to put the card in the left pile. If that's a no, just as before, it goes back to putting the card in a pile on the right, and we're just going to have to include that as an else statement up here, because right now we've checked for black cards less than 5, and then this would be any that are black and greater than or equal to 5, and those get put away on the right. So let's see. Just to clarify here, I've written it out. So these are all the 1 through 4s, or ace through 4s really. And then these are all the 5 through 10s that are black, but we still don't want them. Those are not what I asked for in the original prompt. Also, if we look at this bigger section, this if, keep in mind this is all black cards. All right, so that covers that. And then red cards fit under this else. So we don't have to write if the card color is red here. We really just need to say anything else, because in this case it's only going to be red. So you can see black cards 5 and greater get put in the right pile, as well as all the red cards over here. Then I do want to also check and make sure all of my curly braces are lined up with another so that they are paired, they are matched, and not going to give us a compiler error. And also notice the indentation, how this starts to get really kind of complicated because I've indented 3 or 4 times by the time I'm in here. But again, look how neat it is. It looks very easy to read due to the fact that all of these are indented. And you can see that, again, the syntax is you're going to write some kind of task main, while, or if. After that is braces. And after that is something that's indented. So again, nothing interferes with these braces being above and below each other. A slightly more efficient way to write this, and this is why I pointed out earlier that both of these no's go to the putting a card in the pile on the right, is that we've also learned very briefly in the slides that you could put this and symbol, which is 2 ampersands. So if the color of the card is black and at the very same time, simultaneously, the card value is less than 5, then we can just very simply say those are the ones we want. We only wanted those 8 cards. And everything else, if it's red or if it's a black one greater than 5, is going to get put into the right pile. Notice how many fewer words there are in this compared to this one above, and it's a lot shorter. So this is definitely more efficient. It will ask for 2 conditions at one time. So you can do that, and that is acceptable in your code, as well as something you can kind of see in the flow chart, because both of these lead to putting something in the pile on the right. And notice I didn't have to do anything with the while loop because that's already taken care of from the previous example we did. I just expanded what was inside the while loop, like going back to this one where this was kind of the first draft of the code. So notice now we can identify from flowcharts if there are questions, if there are options, that means an if statement, and if there are big lines going back to the beginning, that is a loop statement. I just want to point out though, some people get really confused between while and if loops because they both take conditions. Sorry, if is not a loop, while loops and if statements. And let's do an example of that. So if you were to take out this if the color of the card is black and then else options here and change that into a while statement. So here I made it while the color of the card is black, do all this. That would still work. The problem with this though, and I took out the else and just had this step here that everything should be put in the right pile. The problem with that is, let's say for example you get a black card. Actually, let's do an example where it works. So let's say you get a red card. So while you have cards left, sure, we're going to do this. Let's say you have a red card. So it's going to skip over this entire while loop and just go to putting it in the right pile. Perfect. That's exactly what we wanted. All right. Then the computer is going to check and see, are there cards left? Okay, let's say we get a black card now. So while the card is black, let's say it's a black 10, so it's not going to fall under this category. It's going to go here, else, and that black 10 should go and get put in a right pile. And that's fine so far, but it's going to come back out here and read this next step. So you just got rid of a card. You can't, there's no repeating this loop right now, so it's going to go on to the next command. And if it says put something in the right pile, but you don't actually have a card to sort at that point, it already got put away, then the computer's going to get confused, and at this point it might get, I could be a compiler error, it most likely would compile, but then just kind of get stuck and confused here. So in order for you to have 2 options, it needs to be an if and an else to be put in the right pile. because this while is going to be expect and go around and around. It's also not going to make much sense when you've put something away and then it says check the color of the card when there is no card in hand. So while and if loops, if and while loops are not interchangeable in that way. All right, so you can check out the next video for more help on some actual robot C code that would interact with your VEX testbed.